In this video we're going to talk about decision criteria under uncertainty. An outcome may be either known with complete certainty or it may be unknown, in which case we have a lack of knowledge. With risk, we assume we have knowledge regarding the probability distribution. So we have an emerging distinction between risk and uncertainty, and it's quite a fundamental and big difference between the two. So with risk, we have some indication as to what is likely to happen. But with uncertainty, we may know completely what's going to happen, in which case it's not uncertain, or, generally the case, it's unknown. We have a lack of knowledge. So when we deal with uncertainty, we're dealing really with a situation in which we have no knowledge at all. We're making a decision with nothing to help us. With risk, we have some indication as to what's likely to happen. So we have a probability distribution. With uncertainty, we have no such distribution. So with uncertainty, we have no knowledge of the probability distribution. It's almost guesswork. So therefore, we can undertake decisions in three ways. First of all, with certainty. Well, if we undertake a decision with certainty, it's well, we know exactly what's going to happen because we're certain. We're certain about the circumstances. We're certain about the issues that impinge upon the decision. So it's certain. If there's a risk, then there's a probability that certain outcomes may arise. We may know what that probability is. We don't know if the outcomes will arise. We just know the probability. If it's a 90% probability, it's pretty good. There's still a 10% probability that it won't arise. So we are still taking a risk. And the final way is uncertainty. Uncertainty is when we have no idea. We have no idea of the probabilities. We have no idea of the probability distribution. We simply don't know. We have to make a decision faced with complete uncertainty. Now, when we talk about risk, we can have objective risk. Objective risk is the type of risk that we can measure. For example, tossing a coin. What's the probability of getting ahead? We can toss the coin many times over until we work out what the probability is. Generally speaking, it should be 50% of the time. Sometimes this is known as Bernoulli risk, named after Bernoulli, who did a lot of work in probability in the early days. But as far as we're concerned here, objective risk is measurable risk. It's risk that we can, it's based on statistics and it's based on calculations. So that's what we mean by objective risk. Now there is a second type, which is subjective risk. And this one is really based on experience and guesswork. It's based on what we believe to be the case. I could ask you, will it rain tomorrow? Well, you may go for the weather forecast and you may look at meteorological data online and eventually come back with an answer and say, yes, it'll rain tomorrow. But really what you're saying is there is a probability that it will rain tomorrow. And I don't know what the probability is. You could say it's 40% likely to rain tomorrow. Where'd you get 40%? Well, it's based on experience and it's based on guesswork. It's subjective. It's a subjective probability. With uncertainty, we have no insight into the future. Uncertainty is we just make a decision because we have nothing to base it on. But we have to make the decision, so we base it. For example, a business person investing in a piece of machinery that's going to last 20 years. Well, we don't know what the world's going to be like in 20 years or in 10 years' time. So there's no insight here. There's nothing to help the person make the decision. We don't know what the return on the investment will be in 10 years or in 20 years' time. It's uncertain. Now let's go back over these types of risk. We have objective, subjective distinctions. Well, let's look at the objective one. Here the probability distribution is known, and with subjective we allocate the probabilities. The distribution itself is unknown. So with objective probability it's worked out using statistics. There's past data which indicates what's likely to happen. With subjective risk we allocate the probabilities. We make a guess based on as much information as we can collect and analyze, but nonetheless it's a guess. The probability, objective probability, is measured in terms of what we call relative frequency within a confidence interval. For example, the probability of heads when we toss a coin. Well, it's the total number of heads that we observe if we toss the coin many times, divided by the total tosses of the coin, the number of times we toss the coin. So if we observe that 49 heads appeared when we tossed the coin 100 times, we would then say that, well, the probability of getting a head is 49%. That is possible. We know that if it's unbiased and in a perfect world it should be 50-50, but when we do it in practice it might get a slight variation. For the firm, for the business, businesses don't, generally speaking, have repetitive events to rely on. So objective risk is not something that companies generally have. Buying a new machine is a new venture for the business. There may not be statistics about the performance of the machine. Entering a new market, there are no past statistics for this to help the decision makers decide the best course of action. So there are no repetitive events. So risk in business is, generally speaking, subjective. And of course overlaps significantly with our idea of entrepreneurship. The entrepreneur is the person who makes the decision. If the entrepreneur is correct, they make a profit, and if they're incorrect, the business closes down. Now, the next question is, when does the probability converge to the true probability? Go back to tossing the coin for a second. If I toss a coin once, just once, and it comes down heads, if I only tossed it once, would it be right for me to conclude that every time I toss the coin it'll come down heads? The only piece of information I've got is I tossed the coin and it came down a head. That doesn't mean that it'll come down heads every time. If I toss it twice and it comes down heads again, now the evidence is starting to suggest that every time I toss the coin it'll come down heads. Well, it's not true, but how many tosses do I have to make before I find out the true probability? If I toss it 100 times, how many heads, how many tails? I might have to toss it 1,000 times, or maybe more. But at what point does the probability converge to the true probability? In life, I suppose we insert common sense and we say, well, let's do it a couple of 100 times or whatever and we'll see what happens. Or we try to work out a priori, we try to work out from first principles what should happen. We know that the coin should come down half and half heads, half tails. So for business, the use of objective risk and objective probability that's, generally speaking, a non-starter, because we don't have repetitive events, generally speaking, in business, and we're not also sure that we know when the true probability emerges anyway, and we can't perform experiments. It would be too costly and too dangerous for the business, so we can't just collect the data for its own sake. So let's look at the criticisms of the objective approach. By relying on repetition, they cannot allow single events to be defined. So because it's based on repetition, if we only have one go, we either buy the machine or we don't. We only have one go. So we can't use objective probability. We only have one event. Objective probability relies on knowing the probability distribution, which will be worked out by performing the same experiment, if you like, over and over and over, tossing the coin over and over and over and over to find out what the probability is. But a single event, it doesn't work. What point, as I said earlier, does the probability converge? After 10 events, or after 100 events, after 1,000? Who's to say? So, two major problems with the objective approach. All reasonable people can be in agreement about the probability inherent in a given system. Therefore, the subjective approach may be the most appropriate. People with experience and with a lot of common sense and logical minds sitting around looking at some decision may have a better chance of working out what the probability is by looking at the advantages and the disadvantages and what may happen, and doing an environmental audit and looking at different circumstances. They may be able to come up with a better indication of what's likely to happen. Now, the subjectivist approach, well, a measure of the degree of confidence of an individual in a certain outcome. That's what it is. It's a measure of the degree of confidence of an individual in a certain outcome. Like the business person deciding to invest in a piece of machinery. They don't know nobody knows what the outcome of that will be in 10 years' time. But the person making the decision must have confidence in the decision and must feel that it's a good decision based on experience and an assessment of likely future risks. With the subjectivist approach, of course, personal differences are recognized and accepted. If two of us decide on what's likely to happen to the weather in next Sunday, I might say it's going to rain with 50% chance, and you might say it's going to rain with a 10% chance. We are different. We have assessed differently. We are different people. In order to make a decision based on our differences, we'd have to get more people involved and take their assessments as well, and do some more research. Go to the meteorological office and pick up some data and try and work out, see what the real experts are saying, and then try to agree a figure. It's the case that individuals with the same experience may have different probabilities. It depends on our propensity to risk, partly a reflection of our personality. Some people like to take risks, some people don't. So there is an issue about simply our propensity to risk. Some love it, some don't. The objective goal is to predict, whereas the subjective one is consistency in decision making. The objective probability is to try and predict. Wants to know what the probability distribution is, try to make some prediction about the future. With the subjectivist one, it's trying to get a consistent decision. It's trying to get a decision that makes sense giving all of the facts, and that most people will subscribe to. Most people will say it's a reasonable decision given what we know. The information that the decision maker must possess is reduced when the subjectivist approach is adopted. Subjectivism needs less information. But clearly, the more information that the decision maker has, the better the decision is likely to be. But in reality, we could make a decision about whether it's going to rain next Sunday simply by, I say, it's 50%. I'm not doing any research into it. I just believe it'll be 50%. There you go. And you could say, well, I believe it's 10%. You're not doing any research either, so we have a difference. We disagree. Let's leave it at that. Let's just disagree. So we have virtually no information. We have no data here to make our predictions about the weather on Sunday. We just make up figures. But to use the subjectivist approach, it's always advisable to pick up as much information as possible to make an informed decision. Make a decision based on facts and figures where possible. Information is no more or less than the individual has at the moment. That's what information is. Information is what the individual has. We can't say that what the information that the person will have in the future is information, because the person hasn't got it. So we make our subjective decisions on what we know right now, not what we're likely to know in the future, because we may know something different in the future or we may not. So decisions are always based on what we know right now. Now, criticisms of the subjectivist approach. First of all, we must consider the quality of the subjective decision. The quality of the decision is a function of the experience of the decision maker and the amount of information that was available that could have helped in making the decision. And also I suppose the history of success or failure on the part of that decision maker. I mean, it's interesting that some entrepreneurs continue to make good decisions and their companies get bigger and bigger and better and better. Other entrepreneurs make one good decision and after that it seems to be downhill. So we must look at what leads to good quality decisions. We may require higher order probabilities. For example, what's the probability of him being right? So we have a person who's going to make a decision, try to say, well, the chances of rain next Sunday is going to be 50%. So some person said that, and I have to think, well, what's the chances of that person being right about that probability? Well, if I said that person is right 40% of the time, I think, and that person saying there's a 50% chance of rain, then really there's only a 20% chance of rain, because the person is wrong a lot of the time. And besides which, it was all just a subjective probability anyway. So sometimes we have to look at higher order probabilities. What's the probability of him being right? And how are probabilities allocated? How do we work out, if we're going to invest in a machine, what the chances of success will be in 5 or 10 years or 20 years time? How do we actually work out that? How do we say there's a 60% chance that this will be a highly profitable business based on the purchase of this piece of capital equipment? How do we how do we get to that 60%? How do we work it out? And related to this is how are feelings transformed into numbers anyway? If I really believe that some business venture is going to be successful, and I say, look, there's an 80% or a 90% chance this business is going to succeed, how do I get the 90%? Why not 87% or 92%? Why did I get 90%? I just made it up. So how are feelings transformed into this, and how do we allocate the probabilities between different ventures, between different decisions? So the subjectivist approach has got issues. So when consistency is required, we use the subjectivist approach. That's what we've come up with. Secondly, data is not always available, so sometimes we're forced into using the subjectivist approach because we don't have data. The problem is that business events are not always repetitive. Sometimes we only have a one-off, and if we have a one-off, it's difficult to calculate a probability. Well, we can't. It's like tossing the coin once. It comes down heads. Is it right for me to say, therefore, that every time I toss the coin, it'll come down heads? Obviously not. So a business events are not always repetitive, and that's a big problem. So the subjectivist approach is probably the only approach available. It's subjective probability. It can't be objective. We can't work it out mathematically or scientifically. And with the subjective approach, we can't force individuals to have the same probabilities. There will be a diversity of opinion. Should we invest in this machine? Well, if you ask all of the managers involved, some will say yes, and some will say maybe, and some will say I don't know, and some will say absolutely not. There will be a diversity of opinion. And then there is an issue about getting some sort of consensus, some sort of agreement, and some sort of greater understanding of whether the machine should be purchased or the investment made. And that might be done through long discussions, trying to collect information if possible, seeking the opinions of experts and so on. And out of all of that, a decision may be made. But it is still subjective. So in this video, we've looked at objective and subjective probabilities and objective and subjective decision making. We've contrasted with uncertainty. And that really is the burning topic in this area. We have a threefold situation. We have decisions under uncertainty, decisions under risk, which are objective or possibly subjective, and we have decisions with certainty. The decisions with certainty, these are straightforward and obvious. So that concludes this talk into uncertainty and risk and uncertainty, and let's leave it at that. So thank you for watching.